So hello, everyone. Thank you so much for joining us here. Um, so I am so happy to be able to introduce Caston Day, one of my colleagues at NCSA, definitely one of the bright lights at NCSA, rising stars. Pick your analogy. You've made quite a splash in the organization, so really glad to have you here. Tiny bit of background. Over the summer, Gordon and I do what we often do for fun, which is write software. And Gordon had come up with the idea of trying to ingest the papers that came out of the SNOMAS process into ChatGPT and be able to ask it general questions. And I found like this fairly useful, amazingly useful tutorial that was already, 4 months old, but it was still useful. And we started playing around with it. And then when I started asking questions on NCSA Slack, Caston said, been there, done that. It already works. Why don't you try this out? And sure enough, we tried it out and it worked. So I am not going to give it away. I'll let Caston describe what you're working on. And then we want to definitely have time for questions because I think a lot of people here are trying these things out. So take it away, Caston.
Hey everyone, thanks so much for letting me talk about this. So I'm going to start with a specific example, but since y'all are a bunch of talented physicists, I'm sure you'll pick up on the general case really quickly. So let's start with a specific example. And then I'm hoping after this, each and every one of you, if you want to, can make your own chatbot with your own documents. I'll give you the link in a moment. And if you put the name in the Zoom chat, I'll give you free GPT-4 access for a couple days until I remember to take it away. So lots of incentive to give it a shot and get some real value out of this meeting during the meeting time. Okay, so here we go. Here's the specific case. I'm talking about the future of education, and this is the fastest and lowest effort custom LLM I can imagine. So I have a cheeky domain name, illinois.guru. There's a couple domain names I bought. And the point here is to be an AI teaching assistant that's an expert on the documents of a course at the University of Illinois, for example. So the professor uploads the syllabus, all the optional readings, all the slides, anything and everything. It's kind of like a black hole you can dump things into. And then people ask questions, and it's just like ChatGPT, except we link directly to the source material and provide citations. In this case, 13 citations to answer your question. And then, we really encourage people to look at the primary sources. We don't want to eliminate the primary sources. We want to make them easy to find. So it's kind of in between a chatbot and a search engine in that way. It's really good at search. We have a whole litany of features to make this possible and easy to use. So like Google Docs, you can change the visibility. We support all different file types. And what's really revolutionary for teachers is they're getting unprecedented visibility into the types of questions students are asking. So this is a semantic map of questions that real students are asking in a course that we've launched at Illinois, electrical engineering course. And in this map, things that are closer together physically are more related and further less related, like PCA type analysis. And it's just a really delightful way for professors to kind of understand what their students are curious on. And the diversity of questions is really astounding. So, when you give people the ability to ask anything, turns out they ask some weird things. And we do all sorts of hierarchical topic modeling to make the maps easier to navigate. Of course, this is all powered by your documents, so you just got to upload some PDFs, Word, whatever. We even web scrape different websites. And so if you go to our URL here, illinois.guru/new, you can make your own project today. And in this case, this is an old version of the video, but we'll web scrape a website, and then it'll be able to answer questions based on the content of that website. One place this works really well is supercomputer documentation. So we have a couple on the homepage if you go to illinois.guru for the NCSA Delta supercomputer. And it's amazing because you'd be like, how do I do this one exact thing that I need? And it'll tell you how to do that in the context of Delta using the modules and pre-installed packages that Delta already has to the best of, the best combination of all those things. So yeah, the ability to get very specific answers in the context of a set of documentation is really helpful. So that's the conclusion here. And I encourage you guys to head over to illinois.guru/new We don't have a link to the new thing on the homepage yet because it actually like costs a little bit of money anytime someone makes something, but I'm more than happy to invest that money into this group's excellence. So we'll take a pause there and see where we want to go to next. I have a couple other products I could talk about. Since this is all kind of powered by GPT-3 and 4, you might imagine that the inference costs, like we end up paying tons of money to just run GPT-4, really expensive to run, via the OpenAI API. And so I built my own exact clone of the OpenAI API like Python package so that I could now run my own models like Llama 2 out of Meta in replacement. So I can show an example of that instead of my chat with Ben. Here's my announcement of the Llama 2 API, which is at api.kasten.ai. And the whole purpose here is to give researchers at Illinois, free language model access in the simplest way possible. And let's turn up the number of completions here, turn up the maximum length a little. And so you guys can go here as well, api.kasten.ai. And this runs internally on our GPUs. And the real benefit is it's just super easy to use. And I actually build, I've never seen someone do this before, but I build on top of the OpenAI API. And you can really just change the base key here from their backend to my backend. And then all the same endpoints still work exactly as theirs do. And I support all the same parameters and everything you want to do, or you can do it, via web requests and curl commands. And it's all like exactly the same as their API because I'm using their package. So that's been a really nice way to have a drop-in replacement to say goodbye to huge OpenAI bills. My goal here is to support 100% of the models on Hugging Face Hub. So you may have heard of Hugging Face. It's like the GitHub of machine learning, and it's where everyone hosts and actually puts the bits, puts the data for their large language models and all other types of AI models. It's not just NLP. And so I'd really love a way for people to just be able to specify the name of the model they want to run, and then they have instant free inference access because we're running it on NCSA GPUs. Now, it won't be free. It'll be more like NSF funded projects or something, but yeah, this is what's going to happen as the open source models catch up to the closed source models. And so they're not quite there yet. The Llama 2 models are actually significantly worse than I thought they'd be. But they're also like quite good. So, it's not the end of the world. Okay, and then let me just highlight one last project that I'm really excited about here. Give me just 1 second to grab this link. Okay, that's the code. And here is an example. No, let's. Boop, boop, boop. Here's the example. Okay, so now how do we make these LLMs? Like I'm building a website that answers questions on your documents. But when I built that website, it actually helped me build the website way faster. So my website is actually like 90% written by AI. And I just work at like a higher abstraction layer. And I really think about it as like, maybe C, not even C++, like assembly/C to Python is what Python is to prompting. And so now I think more on the level of prompting, which is also kind of what a manager does. I think about on a level of delegation. And so what I'm trying to do here is have a team of AI coding assistants that work directly on GitHub. And GitHub is actually this really natural place for multi-agent collaboration. It's like, it's such a perfect fit. And as soon as I thought of this, like, it was like Wu Wei in Buddhism, or like effortless action, and it just fits really well because you have the CI/CD pipelines that kind of check for errors. That AI often writes errors, and so having it inside your CI/CD is just like a really natural place to have it. and like really natural level to review the code written by your AIs. And so the way this works is you basically just open an issue or you open a pull request on GitHub, and the AIs will try their best to answer or implement whatever you're talking about. And so, for example, in this one, and this originally started as an issue. So I open an issue being like, implement a Flask server that listens for these things. And I write a whole little spec. And then it says, okay, I see you opened a new issue. Let me try to implement that. It writes the files here and has like, somewhat decent code, at least good starter code. And oh yeah, this one I was really interested in API rate limiting because I need to implement rate limiting in my own APIs. And then the benefit here is that you have an interaction, a back and forth process. So it writes a couple files. It says, I did this. Let me know what you think. And I said, oh, please add these things. I need a data model for users of a SaaS app. Okay, I'm implementing this. Okay, now I've thought about how to do this. Here's what I'm doing. And it creates a couple more files. And so it created this models file. It updates the app file to work with the new models, and it updates the requirements. And then you can look at the exact diff, of what it's doing in each little iteration. And so this is just a really nice kind of level of abstraction for working with AIs. And I think we're pretty close to being at the level of a junior developer, right? So this is implemented as a GitHub app that I wrote, and I call it Little Junior Dev. I want it to be a really similar experience to having a remote junior engineer, which it's debatable how helpful a remote junior engineer is. They're like sometimes more trouble than they're worth. And that's kind of true here as well. But in certain, if you get the interaction model right, it can be extremely helpful. Okay, so let's pause there. And then I'd love to help onboard you guys to, let's say, illinois.guru/new, where you should just upload your documents, or we could talk about the implementation details if y'all are interested in this general technique called RAG, Retrieval Augmented Generation.
Yes. Oh my God, stop. Wait.
Those are the big three ideas. Yes.
Jim.
So I'd be interested in the details, but also, is it necessary to use GPT-4 for this? Would it be possible to do the same things using ChatGPT 3.5, and we can use our free accounts?
Yeah. So totally, it is 100% the same either way. It works just fine. But 4 is like so much smarter than any other AI model out there that it's like really frustrating for me to talk to any of the other ones. It's like a waste of time.
Okay. But we would be able to. But would we have the tools to be able to do it anyway, even if it's not?
Yes.
Okay.
Yeah. So if you go to any of the courses now, there's a model drop down on the top here, and you can pick between the ones you want. 3.5 with the longer context window, which is actually the same size as 4, is a really nice balance between price and performance. It's like 1/10 the cost of 4, but twice as expensive as 3.5 regular. But having the longer window allows me to shove more documents inside, and so it has better answers.
I mean, would we be able to do this? Would we have the tools to be able to do this on our own without illinois.guru?
Yeah, so it is all open source, and you can run and deploy it yourself. It would be non-trivial to like set all this up and get the infrastructure in place. There's like a considerable number of database dependencies and things like that. But so I encourage you to use the website. I put my heart and soul into it, and I offer a lot of things for free and for subsidized prices. But you can, in principle.
Yeah, I'd be happy to. I just didn't want to cost you money. Okay.
It's okay. Don't worry about it. And actually, the way this works, right, is I was just, if you guys already have your own API key, you enter that in on the bottom here, and that's how you pay for it yourself. If you don't have an OpenAI account and all the keys and stuff, I'm happy to share my key with you for the time being. And in these, this is actually going to give me a permission error. Yeah, too many accounts. But the way this works on the back end is the course creator or the professor can put in their own key that everyone in the course will use. Or if they don't do that, you have to bring your own key. So we have a couple options there.
Mm-hmm. And when you say I'm paying for it, is it personally you? Is it Vlad?
It depends on the day of the week because we spend so much money on this that we have to juggle the ball a fair amount. And right now it is personally me, but that's fine.
What does, just a quick clarification, what does so much money mean? What's that number?
Yeah, we cap it at like $500 a month.
Okay,
And we hit that
thanks.
cap like in the first 3 weeks of the month typically.
Okay. Matthew?
Hi. Yeah, so I guess I have maybe two quick questions. So when you showed the chat with your documents page on UIUC chat, so I went ahead and saw that there's the web scrape there. So while I went ahead and put in some information, but while it said wait for a little bit while this gets scraped in the background. So is this something where in our community and like many others, most of our documentation for the libraries that we build is available on Read the Docs. So can we basically just point this at any Read the Docs page and expect it to scrape that information correctly and ingest it?
Yep, that's exactly the goal, 100%.
And then even better, I think I may have stepped on a bug, but in theory, you can also point it to an XR archive page, and it'll scrape papers straight from there, from archive.
Okay, that's pretty good. Yeah.
Yeah, and we're rolling out more controls on this interface, so you'll be able to control like so it's a recursive like depth first search scrape or breadth first search. We support both. And so in just a few days, we already wrote all the front end GUI code for this. But whenever you start typing a URL, you'll have like maximum URLs you want to ingest, how deep you want to go, how wide you want to go. Should you stay on the base URL or should you navigate to other third-party websites as well? So that's all rolling out within the next, probably by Friday, we'll have that.
Okay. And then I guess you also showed you have your GitHub bots that are interacting with you on GitHub, and you mentioned that things were able to that it works well to have them kind of act as the little junior developers because you have everything hooked into your CI/CD pipeline in general. So one thing that I noticed though is that there's so right here there's like 3 commits in a row. So is this going to basically be like, oh, I'm going to do this one thing, commit and push, and then like 5 seconds later it's going to do this other thing, commit and push? So then you end up getting a huge amount of noise from your CI/CD pipeline because your jobs are getting canceled repeatedly because it's continuing to push, so almost like a pre-commit action going out of control? Or have you been able to say like, hey, do some work locally and then do a think on that cycle to like make sure that this kind of seems to make sense and only then push?
Yeah, so you hit the nail on the head. This is early experimental work, and I upstreamed all of these contributions into LangChain directly. So really excited to have my first pull request merged in there. It's an early V1. This didn't exist 2 weeks ago, and right now every file change is a commit, just for simplicity because of like writing a wrapper around the GitHub API. But yeah, then I just need to introduce the concept of like local versus remote. Right now, there's only really the concept of mainline. There's not really a separation between main and local. Although that's not entirely true. It does know about branches, and it comes up with its own branch names for the pull request that it decides to make and stuff. So yeah, we're still refining that process there. But you're exactly right. It does need to commit less and make more like, human style commits.
Good human style commits.
Yeah. I mean, if you have an incredibly like short and quick CI pipeline, that's fine, of course. But I have a project where a full pass through all the CI takes about like 20 minutes at the moment, and so that's one of those things where I wouldn't want to be getting like 40 emails in my inbox about things getting canceled because of some very talkative commits. But this, I mean, this is generally cool. I mean, don't get me wrong. I'm not trying to say like, oh, this one edge case, like, this is not interesting. No, this is very, very interesting. I have some additional questions, but I've been talking long enough, so I'm going to defer to Gordon.
Yeah, take it, Gordon.
And thank you. That was extremely interesting. Please keep the negative feedback coming. I would love any criticism possible. That's most helpful.
Gordon, if you're talking, we can't hear you.
Can you hear me?
Yeah,
Yes.
now we can hear you.
Oh, okay. Yeah, no, I was just waiting to make sure that interaction had finished. Sorry. But just to quickly understand, do you envision the rest of the time as just talking prompted by our questions, or did you have some material you really wanted to get to before I ask my questions?
No, I don't have any particular material. Please go ahead.
Okay. So first of all, this is insane. This GitHub interaction it's one of those things that I think, at least for me, as soon as I saw it, was like, oh, duh, this is such an obvious thing to do. And I think it's also very cool that you're pushing these things back up into LangChain. This was for the rest of you who don't know this was this library that Ben referred to in the tutorial that he and I started on. So also, this $500 a month, I guess you probably have a couple of courses. So I think this is a brilliant idea for courses, and in fact, I'm about to start my. We're on the quarter system, so I'm about to start this Wednesday, and I'm already thinking, I should be doing something like this. But so when the project that we started, that Ben and I started working on, okay. This is the dollar usage. All right. Yeah, look at the differences in ChatGPT 3.5 is basically in the noise.
Yeah. And it's amazing how cheap that model is. Like, they did an incredible job making it like low price, relative to it's the cheapest AI model to run on the internet, basically.
Is that right? Okay. Yeah, I my suspicion is that, like ChatGPT-4, they just threw everything in there, and now the game is, how do you get that level of performance but like half the price or quarter the price or something like that, and quarter the emissions or the cooling that's required. So when Ben and I implemented this thing, we just basically used LangChain and kind of used some default embedding. So for I maybe as a way of introduction, because I don't know how many people actually understand this process for these. I didn't know there was an acronym for them. You call it RAG? Is that request? What was it? Request answer. No, what was the? I can't remember the acronym.
No, I just wanted to hear your ideas for it. It's retrieval augmented generation.
There we go. Yes, the retrieval augmented generation. Thank you. Yeah, I was. My brain had quickly gone to some things that perhaps should be kept to myself. So that's why I ran out of steam there. But at any rate, maybe you could, by way of introduction, just say briefly what that process is, so that we all kind of have a common context. And I part of the reason is, particularly as physicists, we really like to know how things work. But also in understanding how things work, we can also maybe talk about some of the potential, weaknesses or whatever.
Yeah. So this is like the most ubiquitous technique in large language models right now. And it's kind of the new version of fine tuning. Instead of fine tuning a model, which is honestly like, even though it's technically fairly straightforward, it's still technically challenging. And you get terrible results oftentimes because, okay, so this is a bit of a sidetrack, but I think it's super important. People often throw around the term, like, let's fine tune a model for this on our data. We have a bunch of data, surely we can fine tune a model. That's true, except you lose all of the RLHF, the reinforcement learning with human feedback, you lose all of that like instruction tuning that the closed source AI models are so good at. So if you fine tune a model on your data, it'll turn into a parrot where instead of answering your question, it'll give you similar questions, you know. So fine tuning is really hard because it may have more knowledge of your domain now, but it loses all of that like nice question answering tuning that makes it easy to talk to. So then you'll have to go back to the old world of like pretending this is a quiz and then having a multiple choice answer and then forcing it to make a multiple choice answer guess or something like that, which is, you know, a very difficult style of prompting. So that's why fine tuning is, you know, I think a little bit of a red herring, not always the right tool for the job, especially on a smaller thing. You need a huge effort to do that. And then what am I trying to say? So then after, instead of fine tuning, we do this RAG technique, which is what for a long time, I called this prompt stuffing. So you know, the LLM has a context window that you can put stuff in your prompt and you say, please answer this question using the following documents. If you use the documents, please cite your sources at the end of every sentence using footnote notation. And then we say, document 1 says this, document 2 says this. And so this is kind of what you're seeing in this chart here, although this chart is a little more technical than it needs to be. But basically, we just do semantic similarity between whatever your question is and all the documents we have. And so we find the most similar documents to your question, throw those in the prompt, and have the LLM generate a response using those documents in your question together. And that's RAG in a nutshell. It's just a long prompt and answering using that long prompt.
And that process of finding similar texts has nothing to do with large language models. Is that correct?
Well, no, I think that's unfair. I think because it does. So the way that it does is via embeddings. And so we take your when you ingest documents with us, we chop them up into hopefully meaningful chunks that are no longer than 1,000 tokens, you know, so a couple paragraphs at most. And then we generate, you know, an embedding for that chunk of text. And so then we end up with just a sea of these chunks. And so we have an ocean of small snippets of text, and each one has an embedding using an LLM model to encode it into a, you know, 1,000 dimensional vector. So it's your text paragraph is now 1,000 floats.
But it can be a totally different LLM technology or different LLM model than ChatGPT. You're using a form of large language model to figure out these embeddings so you can find it again later. Is that?
Mm-hmm. That's right. Yeah. So it's not exactly, it doesn't have to be the same language model used to answer the question at all. You can use a totally separate model, but it does have to be like a transformer network encoder.
Why?
Yeah.
Why couldn't I mean, you wouldn't do this for many reasons, but why, you know, this is about similarity. Why couldn't we do something stupid like have if bit 1 is on, the word the appears. If bit 2 is on, the word transformation appears. If bit 3, right? I mean, and then just do vector, you know, do you know, a delta. We call this delta R in physics, but you know, an open angle, a dot product between your question vector and the vector of every single language, and just ask, okay, who are the 5 smallest things? Let's take those chunks and give it to the LLM. I mean, is there anything more sophisticated other than figuring out a better embedding than the seriously stupid one I just mentioned? Is there anything more sophisticated going on?
No, not really. That passes all the unit tests. That would work just fine. The benefit is you get fuzzy retrieval. So fuzzy retrieval in the semantic space is helpful. That's the only thing.
So so this actually leads to, and maybe Ben was going this direction. This leads to one problem that I was having. So we use this for our stuff. We use this OpenAI embedding, and there are times where you ask a short question which contains proper nouns like a name of an experiment, And the embedding just doesn't, because the name of the experiment it's an acronym. It doesn't correspond to any English language word. I'm now making some assumptions, but as a result, although that same name appears in the document database, the embedding doesn't pick up on that as being an important word, and the result is you don't get back any interesting documents.
Yeah.
So
So this is the
oh
fundamental
yeah.
challenge in retrieval. And this is one approach, there's a bunch, but the fundamental problem here, right, is since we're not fine-tuning the weights of the model, if the answer is not in the sections of documents you happen to retrieve, and we're very limited by how many we can retrieve. We only get 10 pages, like 10 PDF pages of space. So out of the thousands of pages you could upload, we need to pick 10 and make sure that those are the right ones. So if we don't get it, then we're really screwed, and we have like no hope of answering the question typically,
Exactly.
unless it happens to be on the internet. So getting the retrieval right is crucial. But this is the same for Google. If Google doesn't have it on the top results, then you probably won't see it, and it will never get there either. So we implement a lot of things behind the scenes to make this better, like hybrid search. It addresses your exact keyword problem. Hybrid search is this kind of colloquial term. It's getting more popularity, but it's basically just a combination of keyword-based search, like kind of more traditional. We use what they call the BM25 model, which is just a really classic keyword ranking model. And we use that along with the embeddings so that it really helps those keyword retrievals. Multi-query sometimes will take your question and rewrite it into multiple different styles, and then we'll retrieve using all of those questions, with yours like getting a little bit more weight. Bunch of other ones like parent document retrievers helps with like the cutoff between chunks. So if we have a document, maybe we happen to retrieve this chunk because it's really similar to your question, but that's like the intro to the answer. And then the next paragraph actually contains the answer instead of like the fluff intro. And so this method really helps like to unify that whole thing. But the fundamental challenge here across all of this, and this is true, like this is one of the central problems in LLMs today, is the context window size is too short. And so we just can't fit enough in the worldview of the model at any given time.
Is the context window something that is built into the training, or is that just a question of cost?
No, it's a lot of things. Yeah.
All right.
So the fundamental thing is that attention in this multi-head attention model is computationally it's squared on the sequence length. So as we add more sequences, the computation is squared with each one. And imagine the cost of GPT-4 with giving it one extra token now makes it, $500 times $500 per month for one more token. So it's a hard problem, but we're getting there.
Okay, cool. I should stop, and I know Matthew had more questions, but it would also be great to hear from others who have been quiet so far. But while people are thinking of a question or two, I just wanted to point out that this website you're looking at right now is this. The LangChain website you were looking at for the documentation, that is this library, which basically makes all of this very easy if people want to do these things on their own. Although I have to say your website looks incredibly polished for just straight document back and forth. But okay, other questions, other queries.
So one question I started thinking about is, so you talk about how GPT-4 is so much better than anything else that's out there, and certainly better than any of the open source models. And I wonder, are there trade-offs between, if you were providing your model better and better embeddings, can your model be relatively crappy and still give you decent results? Like, how much of a trade-off is there between having great embeddings and a great model?
Okay, so great embeddings, great model. Obviously the embeddings are important. And I think so the limitation with bad embeddings is that they won't know about concepts that people put into the bot. So you want your embedding model to know a ton of concepts so that it doesn't have any missing holes in its ability to place things. For example, if you have like, physics terms or chemistry terms that it's never seen, it'll just not do a good job putting those into the semantic space and correlating them. Maybe if you have exact keyword matches, then that helps a little, but it really suffers there a lot. So I think that's the main concern, is if you have out of domain knowledge. And that's why we also use the OpenAI embeddings model, partly because it's super cheap and easy to use, and partly because it has longer embeddings than most. Like most are only half as many floating point values, and this has twice as many floating point values to represent a chunk of text. So that's what I have to say about embedding models. They're not, I think, the most important thing typically, but if they don't work, they don't work.
But what does it look like when you set chat like GPT-3 versus 4? If you're giving it, here is like the most relevant embeddings.
Sorry. So what's the question exactly? How would it differ?
How does it begin? How does its limitations begin to show up? Is it just not making sense of the embeddings? And
I think it just wouldn't retrieve them. So in our retrieval system, if your information is not well encoded into an embedding, we're probably not going to find it again to be able to put it into our prompt. And so if you're using embeddings in the traditional way, which is to create a searchable index of documents, and your embeddings doesn't well represent the document, you won't find it when you need it. So it'll be like.
So I'm saying I've found the most relevant documents and including them in the context that I'm now sending to GPT-3 versus GPT-4. Are you saying that 4 will do a better job of within that context finding the relevant information, and GPT-3 might just go, I've never heard of this, even though it's like staring it right in the face?
Yeah. Just think about it as like dumber and smarter. Like if you give the same information to two humans, one person will just like whiff or give you not a complete answer. Also, 3.5 is super chatty and verbose, and 4 is much more concise and to the point. So they have personality differences as well. If you're talking about comparison, so this is like in general just a comparison between 3.5 and 4. 4 is just a lot smarter. It's seen a lot more things in the world that it can talk about. Less chatty, more straight to the point. It's more steerable is the technical term. Like if you ask it, keep your answers concise and to the point and only respond in Python code or something, it'll listen to your instructions much more. Whereas 3.5 will kind of just like ignore whatever you said and give you the vanilla response. Yeah.
Who else wants to? Yeah. Ben, take it away.
Oh, sorry, I was muted. Hi. So I'm just wondering, you talk about being able to prompt GPT-4 to be more or less verbose or things like that. Is there a way in your interface to add that sort of extra prompt stuffing to your interface?
Yes. So we give you full control over the system prompt. So if you come into the model part on the top here, go to advanced, and then here's the system prompt, which if you're not into the lingo, the system prompt is like the God prompt. It's the most important information that the model will always pay attention to. And so things you put in here will dramatically steer the response type of the model. And so you can put in here whatever you want, like I'm only interested in world domination. All answers should serve that purpose.
That's great. Can you use that to kind of tell it to draw more or less only on the documents you've supplied and not use or give a very low weight to its kind of background knowledge?
Yeah, precisely that. And so I've actually done quite a bit of iteration on that exact problem. But it's a balance, right? So GPT-4, I've noticed most of the time, for most cases, anything I give it in the system prompt is harmful. So it out of the box is just really good and really kind of better than what I can think of, because it's a little bit like coding. And I think this prompting is, you have to think about it like a coder where there are edge cases. So if you give it a prompt like only follow the documents, there are situations where maybe it refuses to acknowledge that the sky is blue because the sky is blue isn't in the documents. And so then it makes like really egregious knowledge transfer errors, some, you know, stuff like that. So you can have edge cases in your prompting as well, for sure. However, I have worked on this quite a bit where for our law students, we tell them so the law professor said like, oh, this is using outside knowledge that isn't in my thing. So she gave me this paragraph, like we tell our students that, the long story short, I just used the exact feedback she gave me as the prompt because it was a well-crafted like legal statement about following the letter of the law. And then that worked really, really well. So the kind of people who are best at prompting are a little bit lawyerly. Stephen Wolfram says that expository writing, or writing for the purpose of education, is the best type of writing for prompts. It's clear, concise, technically correct in every line. That kind of writing is really what you should strive for in your prompts.
Thank you.
But yeah, that stuff works really well. And that actually saved us a lot of money too, because people were using, the students, you know, as soon as we gave it to the students, they started asking all sorts of questions, and then they realized that it would answer them. And so then they were using our chatbot for like all sorts of other classes and problems and stuff. And so then we had to change the prompt, like, if the question is not at all related to the documents or the topic of electrical engineering, just tell them we can't respond. And then that really cut down on abuse.
So I'd be interested to hear some ideas from our participants today about applications of this. So we talked about looking at the SNOMAS documents, and I do have a comparison. Gordon came up with some unit test style questions or prompts, and seeing the responses, and would love some feedback on that. But can we think of other applications for this?
Oh, so I really wanted to tell you guys that I'm sure you read a lot of research papers and you store them in Zotero or Mendeley or something like that. This is the perfect application for this tool. Just dump all the PDFs from your citation manager software into here, and then ask it to draw connections between whatever you're currently working on. And it is just the most incredible way to turn your ever-growing reading list into actionable information. And so and that first level of like, oh, I starred this to read later, or I ingested it into my system, that's like the perfect amount of filtering to keep the noise out, but still give you a lot of documents to work with. And man, I absolutely love that use case. I think y'all would get a ton of value out of that. So just, the way I think about it is as a black hole. The more you upload, the better, and it'll figure it out on the back end.
I just want to emphasize. I just want to pile on to what you were saying there. I think this is a great use for this. And one of the things is that while calculating the embedding does cost money, it's trivial. I think I embedded all 650 some odd documents from the SNOMAS white papers, which was thousands of pages. I'm not sure how big it was, but it's a big ass number. And I think it cost $2 using the OpenAI embedding. The thing that costs money is when you query it. So your idea of just using this as a place to dump everything, as a research buddy, I think is completely the obvious thing to do, because piling it in is dirt cheap. And by the way, buying an OpenAI key is also, for those of you who haven't done it, I was thinking, oh, this is going to be a big deal. It takes you like 3 minutes. You have to sign over a credit card, so that's a little scary, but you can put limits so that you don't accidentally get charged lots of money. But it's great.
Yep, that's exactly right. And actually, the technical detail right now on the back end, we actually pay for all embedding costs because they're so trivial. So you only pay for the chat costs. You don't pay for embeddings. just to make it easier on us. And just for note, if you guys do sign up for a brand new OpenAI account, you do have to like complete one billing cycle before they give you GPT-4 access. So you have to pay them once typically before brand new accounts are given GPT-4. So your credit card has to go through successfully once. And there's full details here if you want to figure out how to get around that and stuff.
So I've been thinking more and more recently about how predictable I am, like as a senior developer. Like you could pretty much, guess what I'm going to say if you've hung out with me long enough. What would that look like to replace me? How would you go about that?
Well, I think about it now as a remote worker. Me personally being fully remote and soon to travel the world, I think about how do I manage myself. And so these AI systems, they should behave kind of the same way, where they work autonomously as much as possible, and then they send you emails or Slack messages whenever they're blocked. And that's the best I have for you right now. Oh, actually, no, I do have something even better. This is very interesting. Just one moment. Yes, here we go. Okay, so this is actually how the GitHub agents work. So there's two levels to it. You have one. So sorry, just back up a little bit. Each box is what I call an agent, or a separate instantiation of the AI model. The reason this makes sense is because they each have their own context window and system instruction. And so this, they could all be kind of the same model or whatever, but just for conceptual simplicity, they're separate models that have separate like global instructions and things that they're able to see in their worldview. And so we have one agent that works as the outer loop planner that has like goals and a short list of available tools. And it outputs like a plan in detail. And then that goes into our execution agent that tries to complete one step of the plan. It iterates with a debugger if it ever produces something that doesn't work or has errors, and then it repeats until the planner is satisfied with the one step of the task. Now this guy, since it only has a short task and not the entire goal and plan and worldview and all that stuff, it's able to have more detail about the available tools. And so then it can call on all of our available APIs, documentation endpoints, scientific databases. And so then it tells the tools like, oh, hey, I need some research papers about this, and I want to write some Python that interprets it this way. And we need documentation for that Python library. And so we have all that stuff available. And then, tries to complete one task and goes from there. And so this is how my current GitHub agents actually work. It's all based on this observe, decide, act, like iteration loop of here's what I can see about the world, here's what I want to do, and then actually call those tools. And we have it running in a sandboxed little Docker container, so it can't get too crazy and works out pretty well.
Oh yeah, I think I remember a talk that you gave at NCSA where you took this one step further and talked about like an enterprise with different departments within an enterprise, how their models might talk to each other. Yeah. Go ahead and frighten us now.
Well, yeah, this is super theoretical and it doesn't really work yet, but you could imagine the same way we organize remote workers is a set of information that flows from one person to the next. And so even ChatGPT came up with this whole org chart using ASCII art. I told ChatGPT, hey, can you make an org chart for a technical SaaS product using ASCII art? And it created this exact chart pretty much just all in plain text. So I don't know if that, how well that will work. I think a more realistic version of this in the short term is what we call like a council of experts. So for every question you ask, you get a response from different perspectives. So one person's like, maybe an old lady who doesn't use technology much, or a prime minister who's worried about globalization and stuff like this. And so these AI models actually, I think, can help with mitigating personal bias because they're so good at putting themselves into other people's shoes. because they've read so many people's shoes. They can help you see things from different perspectives, like automatically. So I think that is actually pretty interesting. And it's being used as a political interview thing. So instead of calling people on surveys and saying, like, how do you feel about this political position, we just create a bunch of personas and ask those personas, how do you feel about this political position? And that is a better substitute than phone interviews because it's more detailed and, you know, more patient, stuff like that.
Although frozen in time in 2021 or something like that.
That's true, but you can use, you know, these retrieval augmented generation techniques to augment that. So I think there's a lot of potential there.
True.
Yeah.
And with the H100s, I suspect that at some point they'll start updating, even without evolving, they'll start updating the model.
Mm-hmm. Yeah, totally. And OpenAI certainly can do that because they have all of the reinforcement with human feedback data. They have all the preferences data, so they can, you know, retune it to human preferences at the end each time. Whereas I think that's the most valuable thing. And this is the open source that no one is talking about, is we need these reward models to be open sourced, because then fine tuning will be possible again. And I really hope Facebook and Meta do this, because they spent like $25 million paying labelers to say, which output do you like more? Is it this one or this one? And so they have all of this human preference data, and they have a really good reward model that they use to tune these as like the last step. But they don't open source that. And so as soon as they open source that, then fine tuning will be really feasible again. And everything I said about fine tuning goes out the window as soon as that happens. Yeah.
Which reminds me, I think you may have told me about this, but now I've been seeing more and more about it. Argonne Labs, what is it, trillion parameter model effort, which seems like it's much more applicable to science. Do you know much about it yet?
No, I was in on the first meetings and it seems very cool. But I don't know any status update on it. No, sorry.
Can you define it a bit for us? From your understanding?
Let's see. Here's their Slack. As far as I can tell, it's just an intro message right now. So I don't know. They're trying to do a chat GPT on scientific documents, like that kind of thing. But yeah, so sorry. I actually have no idea where they're going with this. Yeah. Okay, maybe I should point out one last thing. If you guys write code, you should 100% try out Cursor. So it's a exact fork of VS Code. So it is VS Code under the hood, but it's a hard fork. And it's just GPT-4 built in. And so it's the best like interaction patterns ever. You just highlight a couple lines of code and press Command K, and it edits. You type in your prompt and it'll edit that code in your terminal or in your code editor. And you can accept or reject those changes. You can ask it questions, you know, side by side with your code. You can use all these nice interaction methods like @ a function name, and then it'll drop that function into your context window. So you'd be like, oh, write an API endpoint that's compatible with this function. And then it'll write your API, you know, exactly looking at the function you wanted to use. And it just makes it so fast to code. So would highly, highly recommend this. It's the only way I could have done the work that I have shown here today. There's no way I could have finished stuff as quickly and to the quality.
That's really impressive. I'd heard about this thing. I'm a huge user of just the plain vanilla VS Code. And by the way, for many of us, we're at educational institutions, and GitHub will give you a free access to their ChatGPT-4 service or whatever. And the integration in VS Code is nice. It's not as, I don't think it's as good as this, but I'm a little surprised though that given the extensibility in VS Code that they couldn't just make this a plugin. But whatever. Hopefully at some point GitHub and Microsoft will see how cool this is and start pulling some of the changes back so that many people can write these tools. But yeah. I completely agree. I am so much more efficient now. I rarely do searches of the internet. I just, when I have a programming problem, I either write some comments and then the AI fills it in, or I go to a little chatbot that's part of VS Code and ask it a coding question, and it's made me a lot more efficient. It's so nice not to have to open up a web browser. Actually,
Yeah.
it really has replaced the search engine for my technical questions.
Yeah, yeah, and this is significantly better than GitHub Copilot. So if you're using Copilot now and you're getting like you never were sold on it, for me it would only ever like finish my sentence in really basic ways. And I know they started adding new chat features to it and whatnot, but this is like a step change. It's significantly better.
Okay, great. Yeah, I know the GitHub stuff. It only just came out of beta, the GPT-4 integration, which is, the difference is they were using a much less, I think, much less functional large language model until very recently. But still, the integration that I see here and when I read this website looks better than what they have in the current VS Code.
Yeah. I think Microsoft is perfectly positioned to absolutely dominate this space, right? Because they see, or they could see, like how you click on files, the way you type, like not just language modeling, but entire code interaction modeling. And why can't we model how senior developers work inside the entire computer and not just like predicting the words they're going to say? So Microsoft is perfectly positioned to model the sequence of files that someone changes, how they do their debugging, process, and I really hope that they figure that out because it'll just benefit.
But I think things like these hard forks are great. I mean, that you can move much more nimbly like this than than Microsoft really can. So I hope these hard forks continue. It's one of the gorgeous things about open source.
Mm-hmm. Mm-hmm. All right. Well, I think we're right at time. So I'll offer for now, if there are people in IRIS-HEP that want me to pass questions on to Caston, I'm happy to do that. Caston, it looks like you are a member of a handful of Slacks. Probably don't want to add any more ones, but if we ever get traction in this community, we have our IRIS-HEP Slack, which we managed to bring a lot of people from the field, or like software developers of important products, join us because there's so many power users here. So maybe someday we'll have a reason to entice you.
Wonderful. Thank you so much for coming. Please use this free, OpenAI clone here using the Llama model. It's not 100% stable, but it should work for a little while until I come up with a better one. Mm-hmm. And please reach out on email, kvday2. I would love screenshots of any good interactions you have with the model, so I can, or with the website, so I can better tune it to your preferences. Thanks so much. It was really fun.
Thank you, everyone.
Yeah, huge thank you.
All right. See you around. Bye, y'all.